So hello everyone, my name is Walid. I work for the music streaming service Deezer, and this was a joint work with all of my colleagues from the recommendation team. So today I'm going to present a new feature that's available on the service, which is called Track Mix, and which it intends to help users discover new songs on the platform. So the idea behind this new feature was that whenever we ask our users what do they expect from the application, the most common answer is we want to discover some new music, we want to discover some new songs, which is quite understandable. However, whenever we try to use models that have been optimized for a specific accuracy metric and optimized for retrieving new songs and new interesting songs for our users, and that we use them to recommend songs online to our users, a lot of the time they just won't listen to it. And actually, if you think of it, why would they? They are being recommended a song that they've never heard of, and it's scary to them, it's totally unknown, so most of the time you're just connecting to your app and you want to listen to something that you already know of. So we're kind of facing a dilemma where on one hand users are saying that they want to discover new songs, but whenever we do that, they don't listen to it. And so the idea behind Track Mix is to try to bridge the gap smoothly between what we call profiled songs listening, which are songs that are familiar to our users, and discovery songs listening, the ones that are new to them. So how does it look like in practice? Well, it will look like this, at least for me, when I log in, it will look like this, because this is a screenshot of what my homepage now looks like on Deezer. You may not be familiar with all of the songs, but I am. And they were selected precisely because I'm familiar with all of those songs. So no judging, please. And basically, when I get logged into the service now, I get welcomed with a lot of songs that I already know of. And what happens if I select one of them is the following screen. For instance, imagine that today I'm going to select the song Think by Aretha Franklin. It's going to instantly, on the run, create a mix that is inspired from this one seed track. So the song Think that is part of my collection. And it's going to be followed by a lot of songs that are related to this first one. And so this way, we can welcome users with songs that they know and then try to help them discover new songs, and this way maybe not scare them the moment that we try to help them discover songs. So to do this and to realize this, we had to identify in the translation between what were the product needs that were described and what were the recommendation tasks that related to them. So for the first part, the track selection part, where here I have made a plot of all of the profile songs that I see on my homepage, you may have recognized a top-end recommendation case. So it's very common in recommendation services and in online platforms that on your homepage you're going to have a grid layout of a certain number of items, and the top-end recommendation consists of finding an interesting recommendation for the user that logs in. So I want to stress out two particularities of this case of top-end recommendation. The first one is related to the fact that for music streaming platforms, usually users are not going to log in only once, but several times. Like they may come back tomorrow, or the week after, or a long time during the year. And so one of the problems if we actually optimize for top-end recommendation is that whenever a user logs in but their profile or what we know about them hasn't changed, there is a risk that the recommendation will always be the same, which doesn't make for a great user experience. And so this top-end recommendation case is not aimed at being optimized in the sense that there's a perfect setup of recommendation, but most likely we want it to be non-deterministic. And another particularity compared to other top-end recommendation in the industry in general is that this time we're not trying to find top-end new or novel items from the catalog, but we're actually trying to find them among the ones that they already know of. And then for the second task, once the user has selected one of the tracks that were proposed to them that they know of, the task consists of generating on the go, online, on the run, a new mix that is related to this first song. So starting from one song, we want a list of other songs. And so here we've made quite a few decisions to try to narrow down the task. One of them is that we wanted the mix that's created online to be influenced mainly, or if possible only, by the seed track. So the seed track is the track from the profile of the user that starts the playlist or the mix. So the reason behind this is that because it's a feature that's aimed at discovering new music, we felt like if we try to maybe condition the recommendations too much on what we know about the user, it's possible that we're going to overfit on what we know about them, and actually maybe it's going to be counterproductive if you want them to discover new songs and like really burst out the filter bubble. Another thing that we did is that, again, this part is non-deterministic because we want to incentivize users to come back and to try again the same mix, but this time with another result, and possibly a result that is equally good as the previous time. And it's also non-personalized, so yeah, it's like I mentioned just before. So some other advantages that we can see like from this strategy is that we hope that factors describing the users, such as I know their age or their gender, will not be used by models this way, at least not in a direct way. And so we believe that using only the taste, the musical taste of users should be sufficient to keep on recommending great music. And using this for this new feature is a step forward, maybe in the future, recommender systems that are more privacy respectful. Okay, so we tried two methods for the second task, which is going to be the main focus of my talk from now on. One of them is called MixSVD, and it's basically a collaborative filtering model based on matrix factorization. And the other is called Mix Transformer, and it relies on a transformer. So for the first one, MixSVD, this is the most standard of the two approaches. Basically, what we wanted to do was to start with a matrix factorization technique, and we used SVD because in some previous work, we had extensively tried different techniques for another recommendation task, and this was the one that was chosen in the end. So the task in question was basically to take a bunch of songs from the user's profile and try to recommend them some more music that they will listen to, but like this time a bunch of songs. And the learning of this MixSVD is based on user-made playlists. So users on this platform, Deezer, they can create their own playlist and they can arrange them and put the songs that they like into it. So we think it's valuable information to understand that some songs are connected to one another. And so basically what the SVD does is that it builds co-occurrence matrix, a square co-occurrence matrix between a subset of songs of the catalogs, which is still a few million songs, but not every song. And then it factorizes it using singular value decomposition. So in the end, what this gives you is one track per, one embedding vector per track. And in this new latent space, you can perform approximate nearest neighbor search, which can give you a lot of interesting candidates to create your mix. But then again, you don't want to give exactly the top K most similar songs because of the reasons that I mentioned before. So there is a bit of re-ranking behind this. So that was the first approach to generate mixes. And the second one, I'm sorry, this is just a summary of how this is being used in production. So if you remember, the colored boxes are actually songs. The first one is the one that was selected by the users, and the other ones are the ones that are being recommended. And what's happening under the hood is that the song has an embedding. It will be read in a dictionary. Approximate neighbor search is being performed, and after a bit of ranking, you have your recommendation. And this way of having our infrastructure laid out makes it possible to have almost instant recommendation, which is what we want in this case. So the second approach, as I said before, leverages transformers. And as we all know, like, transformers are amazing. But if you've heard what I've been talking what I've been talking about before, you might be surprised that for a task that consists of starting from one song, trying to find a set of other songs using a transformer, because they're more known to be interesting to understand like sequential information, which in the very beginning of our task is not really the case. We only have one song. So why did we use a transformer for this task? Well, it has to do with the fact that if we didn't have only one song in the beginning, but a few songs, like a playlist or the beginning of a playlist, then it could have been maybe relevant to use a transformer, try to understand what is the mood or the meaning behind this playlist, and then try to retrieve some new songs using this transformer, right? And actually, there were evidences in previous works that transformers can be useful for sequences in general and like playlist continuation in particular. And actually, one of those work was from our team. And so what we did earlier this year is that we trained a transformer to complete the songs, complete the playlist of our users with new songs that they have never heard before. And in this task, we actually had a lot of songs, or sometimes not so much, but at least more than one, that constituted playlists made by our users, and we had to complete them. And what we saw is that when we compare the two methods that I've mentioned just before, SVD versus transformer, well, for this one task, the transformer was much better. What we saw was an increase of 70% in the number of songs that when we recommend them, people add them to their playlist in the end. So for this task, it was very, very efficient. And what we thought was that, okay, maybe the new task that we have is kind of completing a playlist, but this time the playlist is only made of one song, right? So it's kind of dangerous to try it, but we still wanted to do it. And I'm saying it's kind of dangerous, and because what we observed during our previous work was that when the number of songs that was available in the playlist to complete was small, the improvement brought by the transformer was also very, very small. So basically, it was much better than an SVD approach or matrix factorization approach when it had enough songs already in the playlist. But still, because we had to solve this first task, a transformer is now available on the service, and it's being used for a task of playlist continuation. So we didn't have to retrain it and find the resources in the infrastructure, especially for it. And so sometimes it does work like this in the industry. If you already have put a lot of work into developing something that is very new and kind of complex, you're really tempted to try to see if it's also going to work on a task for which it was not trained in the first place. Okay, so just a brief summary of how the transformer was trained. So the architecture is a decoder-only transformer, so kind of like the GPT family, but this time it has only one hidden layer. We had tried several ones, but in the end we kept only one. And it is trained on predicting the next songs that are going to be available in the playlist, given the same data set on which SVD has been trained before. And the way that we use it in the end is quite similar to embeddings that we were reading in the first part. But this time, when the first song is known to the system, we give it as the input to a transformer. And there were several versions. One of them only uses the song in question. And other versions try to, from this original song, try to artificially create a sequence, because like we've seen before, transformers are better when there are already sequences available. So like starting from this first song, we try to create new sequences and give this as input to the transformer. But then the rest is quite similar to using an SVD in the end, or an embedding-based recommendation in the end. Okay, so now we had two possible ways of creating our mixes, and we wanted to compare them, so we ran an A/B test. So the A/B test, it happened during approximately 2 months earlier this year. And the goal was to evaluate how much are these two possibilities able to enhance discovery of new musics to our users. And so to assess this and to measure this, we decided to focus on one metric, which was the number of users that collected at least one song during their session. So to collect in our vocabulary means either to add to your favorites. You know, most of these applications, they have a heart that is available somewhere to add to your library, or to add to one of your playlists, because some users just never use the hearts, but instead they like to be organized and they like to add the new songs to their playlist. Also, I want to stress out that we could have used also like the listening times, for instance, to monitor that we are performing good, but we thought that collecting was more relevant to what we are trying to achieve. We're trying to help people discover new musics, and we want them to come back on the same feature. And so if they collect a lot of songs, what's going to happen the next time that they log in is that more mixes, more possibilities are going to be displayed to them on the homepage. And so it's interesting because if it works well, it can snowball into maybe the users discovering even more songs. And so what we saw is this. So if you're not keen on big tables like this, I've put the translation just under. And for this specific task, where you have only one track in the beginning, it's actually more interesting to use just matrix factorization than a transformer. The transformer is not good at this, but at least we did the test. However, this test was not a complete waste of time or uninteresting because we still did learn some things. First of all, for our new users, this time the transformer performed better than using matrix factorization and just embeddings. And a second thing is that it makes people listen to music much longer. So it doesn't help them discover new songs more than SVD, but it helps them listen to music much longer. So we're trying to find an interpretation of why this is the case. And basically, our main clue is that we think that the transformer, it's created representations for all of the songs that were very similar and that in the end targeted popular songs that were more recommended into this feature. And so what happened is that new users, they were kind of happy to see those popular songs because it was familiar to them. And so this way, they could know what's available on the service. Whereas experienced users, they were really not happy with that because they're expecting discoveries, so most likely not too popular songs. All right, so just to conclude, the transformer was not, in the end, a good approach for this one task. However, it still could be useful because it can help our new users, build their collection when they first log into the service. In the end, an embedding-based approach is very performant, and this is the one that is still being used right now. And also, in the industrial paper, there are some details about the engineering of what's happening when people logging, and we have to make them the recommendation. And in the future, we still want to study a little bit more on what happens when you use a transformer for those very short sequences, and especially why we saw such a popularity bump in the recommendations. So thank you for listening.
Great talk, Walid. Do we have questions for Walid? Yes, please go ahead.
Great talk. Thanks very much.
Could you state your name and affiliation?
Oh, yeah. I'm Tao. I'm from Amazon Music. Great talk. Very interesting, and especially cool to see new features, new visual features. I'm wondering for the first task that you have to select the seed that you give to the user, right? Those are the songs that the users already listen to, right? I'm wondering if you group them in some kind of theme or genre to kind of have day-to-day difference, so there's freshness in order to satisfy your not repeating requirement.
Yes. Thank you for the question. So the main thing that we focused on, basically, with this top-end recommendation where each of the items is going to be consumed for a long time, usually what we want is that at least one of these items must be interesting to the user. So for us, we see it as a typical case where diversity is interesting, because otherwise, when there's no diversity, you've basically given a first song that is not that interesting right now to the users, and if you give other songs that are similar, it's very likely also they are going to not going to be interesting to the user. So in this situation, yes, we try to monitor the similarity between the different songs that we recommend, but it's precisely to make sure they're not too similar in this case.
I see. Thank you.
Thank you.
Hey, Walid. I'm Jeffrey from SiriusXM/Pandora. So my question is, the way you do the candidate selection, it seems to be, I guess, other than the randomness, it's like an item-to-item case. Like if you and I have the same C track, we will get more or less the same candidates. Do you apply any kind of personalization, like let's say at the re-ranking stage or something like such that maybe you can take into account my other collects, for example?
Sure. Just to be sure, are you talking about this phase or the following one? Are you talking about this or the one from before?
Not sure.
Okay.
Sorry, could we have the slides back up?
Okay. Yeah, I didn't.
Thank you.
Yeah, I was mentioning, did you talk about this phase or the previous one? Sorry.
Oh, yeah, I guess here, when these are personalized, where, when is this personalization injected?
Yeah. So basically, for current recommendation task, we have a preset of songs that users are familiar with, and it's shared between this feature, and others. So kind of everyone has this set of candidates tracks from their own profile, and for new users, you have to find like kind of hacks to make sure that they're familiar with something, even though they've never interacted with it. So we have specific models for these features.
I see.
Yeah.
All right, thanks.
Thank you.
One final question. So, sorry, is there another question on?
Sorry?
Yeah, please go ahead.
Yeah, so thank you for the presentation. Just one question about here, the profile. So that's based on the timestamp of the user. So how do you define the profiles? Like the user add as favorite, add to their playlist, or they stream multiple times? How do they define this?
Yes. So that's a situation where those kind of decisions are shared between people from my team, the like machine learning engineers or data scientists or research, and people that don't really do engineering but still have an idea of what could be considered familiar to users. So it was kind of like a common decision. In the end, you get it right. Like it's either that they've explicitly interacted with it, or because some people never add anything to their favorites, or some people never add to their playlist. We also use proxies such as how many times they've been listening to it and such like this. But it's this kind of data that is being used.
Yeah, so it's basically aggregate these different signals.
Yes.
And also one more question, why only consider one seed track when you generate the mix? Because like for the transformer, is maybe work better if you have a sequence of seeds.
You're right. So we started from the feature itself, and the feature was we want user to only click on one song that they know of. So whatever the model behind it, we only want this to be like fulfilled. And so you're right that using a transformer for this as is not going to be like really like relevant. So what we did when we used the transformer is that under the hood, with this first track, we tried several ways of adding new songs that will form a short sequence. And with this sequence, it was used as input to the transformer. So not all of the ways are detailed, but we can talk about the ways that we try to form the short sequences as input to transformer.
Okay, thank you.
Yeah, thank you.
And unfortunately, that is all that we have time for today. I'd like to thank Walid for his great talk. And if you enjoyed that, there is another sequence recommendation session tomorrow. I will see you there.